So the other example of where you will have a two-sided limit not exist is when you have oscillations, and this really is just kind of for your information, but it does happen, so I want you to be aware of it. So like if you look at this little dark area in here, that dark area means that the function is just oscillating back and forth between 1 and -1 as it approaches 0. And so all you could really say for this is that, okay, as x goes to 0, the y values are approaching 1 and -1, and that's not a single finite value. So that means that this limit does not exist. So again, what would happen here is you would just say a D and E's because of that oscillation. But that is the second situation where your limit does not exist, is if you have oscillations back and forth that are basically increasing with or increasing rapidly as you approach x equals 0, like the period is going to infinity. Okay, and then the third situation that can happen is this example. And if you look below at this example, you see this dotted line. Now, you might remember from college algebra that this dotted line is actually a vertical asymptote. And with the vertical asymptote, the function is going to continue on, but it's never actually going to touch that line. So it's going to get closer and closer and closer, but it's not actually going to touch this dotted line. So the y value in this case is going to approach infinity. It's not a single finite value, and so formally we would say that this limit does not exist. Now, I will mention we are going to have to talk about this later, because ultimately we are going to say that the limit is equal to infinity, but technically this would be an example of the limit not existing. So this third example is if you have infinite behavior at that limit, then your limit does not exist. So if it's infinite behavior, then it would be it does not exist, potentially.